when we were evaluating the daily tilt factor R B bar, we left the apparent sunrise hour angles omega S S and omega S R undetermined. So, the expressions become available for evaluating omega S S and omega S R when once these values of omega S R and S S could be determined. Now, in order to have a clear idea, let us just have an idea. If I plot the hour angle omega versus theta or theta z in general, does not matter how it looks like. This dotted line is pi by 2, that is theta will become equal to pi by 2 or theta z will become equal to pi by 2, and this will be the typical variation of theta z, that is at the solar noon it will be a minimum angle, and at the sunrise it will be pi by 2 at minus omega s, and at sunset it will be again pi by 2 at plus omega s, right. You can take the expression for cosine theta z. And then give for a chosen phi and delta, you give omega and plot, and you will find that theta z is equal to pi by 2 at omega s given by cos inverse of minus tan phi tan delta, and in general it will be decreasing and it will be minimum at the solar noon time. Now, if I try to plot again gamma equal to 0 only, because that is easily understood, south facing surface, this is pi by 2 theta or theta z omega minus omega s plus omega s. Now, if delta is less than 0, I will have something like this. You can calculate, this will be my so called omega s double dash, which you should be correlating with the notation that we introduced. In other words, the tilted surface when delta is negative will reach theta equal to pi by 2 at a value of omega s double dashed, magnitude of which is higher than omega s. So, of course, we limit all our calculations to omega s, and if I use another color, this may be for delta positive, okay. So, that will be less than the magnitude of omega s. So, you will receive the radiation during this period, not all the time that sun is above the horizon. You can just from the trigonometry of those two relations, you can have these numbers and the figures like this. Now, consider a vertical surface, beta is equal to 90 degrees and declination some positive value, and let us say latitude of 30 degrees. Now, again if I plot it, so this will be your theta z, and this will be your theta, since the magnitude of omega s double dashed is less than omega s, that will be also my so called sunset hour angle for the tilted surface omega s dashed. Now, the same picture, if I continue calculating, it keeps on giving you some value of theta, which is more than pi by 2, which basically means the sun is below the horizon or the rays does not graze past the surface and the surface will not receive any solar radiation. So, by simple optics and common sense, if I plot for this is gamma equal to 0, if gamma is equal to 180 degrees, I should have a mirror image of this. One can set down gamma is equal to 0 and calculate it south facing, then set gamma is equal to 180 degrees. It will be only cos gamma will become a minus 1, and you will find that again you will get the same number, right, omega s double prime when you calculate for gamma is equal to 180 with delta same number and with this and gamma 0, you will get the answer as same number, right. But you do not know which is sunrise or sunset as far as the surface is concerned. If you want to have a real inside idea, you plot it in detail, this theta versus omega, and you will find up to omega s double dashed, the value of theta is less than pi by 2, and from this value to this value, during which time the surface facing south is receiving radiation, it does not, and the remaining time it will receive. So, if I only amplify this particular thing for the sake of clarity, in other words, this is for more of easy understanding. There is a surface whatever you will like to call. This is of course all right. Now, we will ask a question. How do I define the so called sunrise and sunset? Okay. One thing is my theta is equal to pi by 2, right. So, if I look at it, theta is equal to pi by 2, theta equal to pi by 2. So, I can call this is sunrise, this is sunset, or you may call this to be sunrise and this to be sunset. So, I will additionally qualify with my experience of general south facing surfaces, not only theta is equal to pi by 2, d theta upon d omega should be less than 0 for sunrise and d theta d omega greater than 0 for sunset. If you look at a normal horizontal surface or a south facing surface, this is your theta is equal to pi by 2 and theta is becoming smaller. So, d theta d omega is negative and then again this is increasing and it will continue to increase, or the slope is higher at the sunset. So, mathematically we will define that sunrise and sunset are not only just theta is equal to pi by 2, but the gradient d theta d omega is negative if I want to call it sunrise, and d theta d omega should be positive if I want to call it sunset. Now, we will go back to our gamma is equal to 180 delta greater than 0 curve. So, which one will qualify as sunrise? So, this should be sunrise and this should be sunset. Right? Because here onwards, that means the surface starts seeing the sun at, let us say, 3:30 p.m., continues up to sunset. Again, for our own comfortable feeling, next day morning it starts seeing from sunrise up to something like 10 o'clock or 9:30 a.m. Now, if I integrate from here to here, this will be cos theta negative, okay, because it is more than 90 degrees, my R B will be negative. So, initially I was telling a blind condition that R B to be positive, right, because cos theta is negative when theta is greater than pi by 2, my R B will turn out to be negative. Now, if this is the situation, in general, if gamma is neither 0 nor 180, I will not be showing omega s anymore. It is understood it will be limited to omega s if it is more magnitude wise. I can easily say this is for gamma less than 0. I have a more time received during the forenoon than during the afternoon, and the minimum occurs sometime in the forenoon itself, something like gamma is equal to minus 10 degrees. So, this satisfies my theta is equal to pi by 2, d theta d omega is negative, and this is normal non south facing surface, where our relations directly integrating from omega s r to omega s s are valid. Okay. Then I may have something like this. It starts seeing in the afternoon, stops seeing in the afternoon. This is again, it satisfies my condition. Let us say my something like gamma equal to 77, almost towards the west. So, it may start seeing around 3 p.m. and stop seeing at 5, or it may even go like this, wherein it may be my omega s. Okay? In other words, you are towards the west and it started seeing after solar noon and continues to see till the sunset, because it is almost towards. If it is a due west, as a matter of fact, it starts seeing exactly at solar noon time and stops seeing exactly at sunset. So, you can think of degenerate cases, including just the minimum is pi by 2 occurring at solar noon. Rest of the time, in other words, slightly before this orientation, whatever it is, I might be having something like this, and I keep on changing my beta. Let us imagine this to be south facing, so that it is symmetric. This is some beta is equal to 72. I will change it to 78, 80, somewhere it just touches pi by 2. This is no sunshine, but I would call it normal. In other words, in the limit, this is my omega s r and this is my omega s s. Slightly neighboring value of slope beta, I have a omega s r is equal to minus 2 degrees and omega s s as plus 2 degrees, right. If I take a counterpart of this particular, you can say no sunshine period, I may have this is also no sunshine. Like that beta is equal to 90 degrees and gamma is equal to 180, I keep on changing beta slightly and I will just make graze past it, but the angles are less before that and angles are again less before this. So, technically receives sun practically all the time, but not same as normal. In other words, it is a degenerate case of double sunshine, slightly different value of beta, I might have had something like this. So, this is my omega s s, this is my omega s r, which shrunk and tended towards 0. Now, if this is like this, I will get a correct value, whether no matter how you, what is your omega s r and omega s s? It becomes minus omega s to plus omega s. But if I try to do that for a slightly different beta, I have to do from here to here and here to here, not continuously. If I do from here to here, I will get only a negative value. Okay? Now, this is easily understood, I mean rather I do not say very easily understood, it can be understood in one sense. In other words, a surface receiving the solar radiation all the time may be a degenerate case of double sunshine or a degenerate case of normal case of single sunshine. So, these are the two definitions which we have to use. Theta is equal to pi by 2 and rate of change is negative according to our convention as far as d theta d omega is concerned. How do I evaluate it? And why this fallacy? Why for a south facing surface we do not have the problem, but why is it we are having a problem when once gamma is not equal to 0? As a matter of fact, quite a few occasions including in published literature, when so open conditions were set if R b bar is less than 0, set R b equal to 0 is a typical computer statement, which may not be true, right. You got a R b bar negative because your negative contribution is larger than the positive contribution, right, or you might have had R b bar equal to 0.1, where from possible positive contribution some negative contribution has been subtracted. So, either it may be wrongly shown as negative or underestimate. So, these are the dangers, particularly these things will occur if your latitudes are lower, the occurrence of this double sunshine is more, right. Consequently, at low latitudes, tropical locations, one has to be little careful in ensuring that theta is equal to pi by 2 and d theta d omega is positive or negative, but then this leads to an elaborate calculation, right. You have to find out the theta and then differentiate it and find out whether it is positive or negative, etc. Most of the algorithms that were available in the literature present something like this, where you set theta is equal to pi by 2, then it leads to the equation a plus b cos omega plus c sin omega is equal to 0. It is for this discussion, it is not necessary to have exact expressions for a, b and c, though the magnitudes will ultimately decide what are the values of your omega s r and omega s s. Now, you can solve this equation and let us say I do not know whether it is omega s r or omega s s, but omega 1 will be cos inverse of right. How do you solve it? You take that c sin omega onto the other side, square it up and then write sin squared omega is equal to 1 minus cos squared omega. So, you will get a quadratic equation in cos omega, and that is the cause of our problem, because you have squared and taken a root. In that process somewhere a sign is lost, and you will get omega 2 where this alpha is b squared plus c squared minus a squared. Now, these are multi-valued because any cos inverse will give me plus minus principal value at least, and another two values for omega 1 and 2 values for omega 2. Earlier we had two values for omega s or omega s double dashed as cosine inverse of tan phi minus beta tan delta or cosine inverse of tan phi tan delta, and which we according to our notation identified the negative one as the sunrise and the positive one as the sunset. But now we have got 4, and I will just give you arbitrarily some numbers, something like this. If I solve it, I got a minus 87 and plus 87 from the first one, and second one minus 62 and plus 62. Nothing, I do not really intend that they should be less than pi by 2, one can be more than pi by 2, but just to illustrate the point, I really do not know whether my omega s r is minus 87 or 87 or plus 87 and omega s s is minus 62 or plus 62. Also, I do not know whether the magnitude of omega s r and omega s s are 87 or 62, though psychologically I am assuming the first one to be the sunrise. At the present stage of the derivation, not the present stage of knowledge of the humanity, it is not possible to determine omega 1 and omega 2 uniquely. The possibilities are, I may have minus 87, minus 62, which means it starts seeing the sun in the morning and stops seeing the sun in the morning itself, vice versa, like all the 4 combinations are possible. So, yet we have to decide which is omega s r and omega s s, even if the correct omega 1 omega 2 combination is known. So, this is a consequence of solving the transcendental equation for cos theta. But there is a slight advantage that this cosine inverse fortunately gives the magnitude correctly. The ambiguity is whether it is minus 87 or plus 87 or plus 62 or minus 62, but 62 and 87 are real. So, what people were doing kept on adding one condition after the other, and we can physically think that you solve for gamma equal to 0, you will get a omega s dashed minus n for sunrise and sunset normal orientation, and if you set gamma is equal to minus 5 minus 10, I expect my omega s r magnitude to be larger than omega s dashed, and similarly omega s s should be less. So, that is satisfied by the first omega 1 will be closer to my omega s r omega s dashed values, and omega 2 will be closer to omega s s or omega s dash plus values. Then again I will compare with my omega s and then take the magnitude. Actually, these magnitudes are written because omega s we always consider it to be positive, right. Otherwise, whatever is the sign of omega 1 will be taken as sign of omega s r. It is understood for reasonable values that this is true, and as I pointed out right in the beginning, that integration is a continuous from omega s r to s s. So, irrespective of the sign, we can say that if omega s r is less than omega s s normal, you take the sign into account, you take the magnitude also into account, right, no problem. Minus 82 is less than minus 60. So, I may have a omega s r to be minus 82, omega s s to be plus minus 60, still my condition is satisfied. Same thing is true even if they turn out to be both positive, whereas omega s r is lower than omega s s. So, as long as this number game is satisfied, it is a normal period and integration is from omega s r to omega s s. Now, this is where one of our graduate students has come out with an idea. Now, why did we get into this mess? Because we are solving it as a cosine inverse. We are solving it as a cosine inverse because for gamma equal to 0, it is a cosine inverse and there is no sine term. So, if you solve it as a sine inverse, take out that b cos omega onto the right hand side, square it and then express it as 1 minus sin squared omega. Then I will have a quadratic equation in sin omega and solve it. Then I will get a omega 1 dashed to distinguish from omega 1 and omega 2 dashed to distinguish from your omega 2. You will notice that I played a trick, omega 1 dashed with that minus sign, that is a c minus b root alpha, and omega 2 dashed is with a c minus plus b root alpha, whereas your omega 1 will be in other words, this omega 1 omega 2, the discriminant sign plus and minus, they have been deliberately interchanged. Okay. This came after considerable trial and errors, because whether you evaluate your omega 1 and omega 2 as cosine inverse or sine inverse, your in general sin squared phi plus cos squared phi should be equal to 1, be satisfied analytically. It does so if I choose omega 1 dash to be minus and omega 2 dash to be plus in the discriminant term. Okay. So, that is the reason why this looks interchanged. So, now I have got sine is also not such a innocent function. It will give me, earlier as we have written, minus 87 and it will give me how much or 62 and 118, right. If the principal value is 62, 180 minus also will be satisfied by sine. So, I will have a 62 and 118, or of course, if it is minus 62 minus 118, similarly for 87 or whatever the numbers. So, now my ambiguity lies in magnitude, whether should I pick up the 62 for omega 2 or 118, similarly for omega 1 dashed also. So, the common sense says that whatever are common between these two are the correct values. So, I may get a minus 62 as cosine inverse, which occurs in omega 2 as minus 62. So, minus 62 is one of the values and that will be my omega SR, the second one will be my omega SS. So, then I will apply my criterion that so, we shall now have correctly determined and slightly arbitrarily assigning that omega 1 to be omega SR and omega 2 to be omega SS, right, but the numbers magnitudes are correctly decided, and that slight arbitrariness is based upon the physical fact, if gamma deviates slightly from gamma equal to 0, those values should be closer to the south facing values, right, not that they it's completely arbitrary. And still if one wants, one can verify d theta d omega to be positive or negative from the expressions. So, this is only mathematical thing, you have to write it in terms of pick up the sign is decided by minus a c minus b root alpha and minus a c plus b root alpha of the sine inverse functions, because you can see that term and the sign will be positive or negative just depending upon the sign of that discriminant. And you compare the magnitudes with omega s and pick up the sign of this number minus a c minus b root alpha and the magnitude as given by minimum of those two. This is only mathematical way we understood. Determine correctly omega s r and omega s s magnitude and sign, then we compare with the magnitude of the physical sunset or sunrise hour angle. So, I have given examples here which I shall write down, because this print is too small. This first table contains single sunshine orientations with all the types of possibilities I have shown. First one is quite normal. So, latitude 17 degrees, slope 90 degrees, azimuthal angle 0, delta minus 10, with omega s being 87.72 and omega s r minus 87.72, omega s s 87.72. This is after all a gamma equal to 0 surface. So, consequently, though you call it omega s r and omega s s, they are nothing but your omega s dashed. Actually, you have limited to omega s. If you see the plot of this theta versus omega, it is not equal to pi by 2 at minus omega s or plus omega s. Right. At the physical sunrise and sunset, in delta negative, it comes out with a fairly good angle of incidence. Okay. That means lower than 90. The same thing, a positive delta and a slight positive gamma, that means towards the west, you can see that omega s r is considerably nearer to the solar noon time, away from the sunrise, and the minimum occurs almost near the sunset, because my gamma is 30 degrees, which will have approximately correspond to sun's rays being normal plane to the surface around 3 o'clock. So, it will still not have theta is equal to pi by 2 at sunset. So, it continues to see even at the sunset, which is obviously because it is due west. Then the other one is again yes, beta 90. This same thing, case number 1, which is reproduced except with a positive declination. So, this as we have been discussing, For generality they are being called omega SR and omega SS, but otherwise they are just your omega S dashed, because it is a gamma equal to 0 surface. This demonstrates for positive declination theta will be equal to pi by 2 at a value after the sunrise and considerably before the sunset. This is a quite a again gamma is equal to 135 degrees. That means it is in the beyond west. The outer normal is between the west and the north projection of it. Okay. And delta is minus 23 degrees. That means December, and you will find that of course, this is your omega, and you have a minus omega S and a plus omega S. This is theta, 90-degree angle, and what you will find is, so it starts seeing and of course you limit it to omega S, because it is fairly even beyond west. So, it starts seeing quite late in the afternoon, maybe 4 o'clock. These diagrams are not so much to the scale, but illustrate the point that it should be in the afternoon, and during the forenoon it does not receive any solar radiation. So, this is phi is equal to 17, beta 90, gamma 10, and declination 90 degree 19, and this only shows both omega SR and omega SS are within the sort of afternoon only, because it is only gamma is equal to 10 degrees, right. It starts seeing maybe around 12:30, that figure is not that clear. So, phi is now one reason why we are sticking to this 17 or low degree and 90 degrees slope is that you will have that more of examples of double sunshine at lower latitudes, and beta is equal to 90 is chosen. If we could have chosen even 60 or 70 or 40 or 50, whatever you want, but exact symmetry to understand the reversal of the theta variation cannot be seen if you choose arbitrarily beta. If beta suppose is 35 degrees when it is due south, right, again you have to put beta is equal to 35 if it is due north, but measured from the behind. So, compared to the previous angle, it will be 165 degrees, you have to turn it towards the south. So, this is to demonstrate mainly that when your declination is positive, the sunset or apparent sunrise angles for the tilted surface will be within omega S, even if gamma is not equal to 0. That is why low gamma is chosen. If you choose a gamma is equal to 40 degrees or so, it might go beyond omega S, right. That means, this kink, or let me draw it, it should be so, this should be after solar noon, and this is omega SS. because we started with a very small gamma towards west. So, it starts seeing slightly after the solar noon, and because it is so small and it is a summer or delta 19. So, my in general sunset hour angle should be less than omega s had gamma been equal to 0, but since we chose a small, it goes towards omega s, but still less than omega s. The last one is a typical south facing maximum negative declination, and you will have a fairly low value of angle of incidence at sunrise and sunset, physical sunrise and sunset. That means, in a winter time it will receive all the time. So, and since it is low latitude and high slope, the sun's rays are almost normal to the surface. So, these are the examples of single sunshine orientations. Now, here are these are examples of double. Let me go through. This is somewhat cleverly done in the sense that delta is 23. So, it is a positive declination, wherein a south facing surface will receive part of the time only. Beta is equal to 90. Consequently, again when delta is 23, it will be a small duration, and then instead of gamma is equal to 180, 170 is chosen, which is almost 180, and you will find that these were actually calculated for various values of omega and then plotted, though may not exactly be the scale. So, this is it looks a little disheartening or rather uncomfortable to say that sunrise is in the afternoon and sunset is in the forenoon, but this is the apparent sunrise as seen by the surface according to the definitions we gave, that angle of incidence should be equal to pi by 2 and my angle of incidence should be decreasing if it started seeing the sun, and it should be increasing if it is about to stop seeing the sun. So, it satisfies that criterion, and if somebody is a little uncomfortable saying that it stopped seeing the sun in the morning, started seeing the sun in the afternoon, calling it thereby, what we can imagine is this is when it started today, and again it continued to set tomorrow morning at omega s. In between, the sun was below the horizon, and hence the surface did not receive the solar radiation. And yes, this is that absolutely degenerate case. So, phi 17, delta 17, beta 90, gamma is equal to 170. This is very easy to understand when once you have got beta 90 and delta 17 equal to latitude. Okay. And as a matter of fact, one can I suspect this is exactly theta noon equal to pi by 2. Okay. And one can verify that if the surface is vertical and latitude is equal to the declination, at solar noon time the sun is vertically above at that location. So, any vertical surface, the rays at solar noon will be grazing past that. Okay. So, that is the little trick of choosing declination equal to the latitude. That is also the reason for sticking to the 17 degrees, because this does not happen at more than 23.45 degrees. Okay. In other words, if you look at it this is theta noon is pi by 2, but you are receiving the solar radiation during this period and this period. Okay. Theta is less than pi by 2 except around the noon time. This is again it seems normal, omega SR, yeah, this is exactly not normal. What you will find that is 3 phi is equal to 25, beta is equal to 90, gamma is equal to 150 and delta is 23. If you calculate and you have got the plot something like this, so you determined according to our criterion to be omega SR, and this is my omega S. What happens was you got a omega S pretty large value, okay, which runs into the night. Consequently, you set it equal to a negative number of minus omega S in the morning. So, it looks as if it is a single sunshine period, but in reality it must have touched a theta is equal to pi by 2 sometime between plus omega S and minus omega S, right. If complete calculations are done, that is why it is written here as minus omega S is equal to omega SS, because you are limiting it to that, you got a larger value. So, you limit it to that. Next example is of course, the whole idea is to show something like normal, but discontinuous, like number 1 omega SR is in the afternoon and omega SS in the positive, morning, forenoon, sorry, and the other case is degenerate that can go to noon time. The last one is that second one omega SS is beyond simple omega S, and the fourth case is phi 17, beta 90 degrees, gamma 175 and delta 23. You got you have something. Sorry, it is okay. So, it starts seeing sometime in the forenoon itself, sees all the way up to sunset, and again sees from the morning till some omega SS. That means, both omega SR and omega SS occurring only in the forenoon. That is the whole idea compared to other things that are being different. Okay? So, we shall continue with this in the next class, and including few more cases of double sunshine and no sunshine case.